Spectrum PCCF filament, wet versus dry. What do you think? Is there any bigger difference in the strength? Let's find out together. Hello, welcome to another filament testing video. This is Spectrum PCCF, polycarbonate reinforced with carbon fibers. And this is only 0.25 kilograms spool. I bought it myself. I placed some order and I was missing 10 euros to get the free shipping, and I found this small one. So I'm curious anyway about this filament and I bought it myself. So this is not a sponsored video by Spectrum, but it is still a sponsored video. Actually, the whole channel is sponsored by Polymaker, and I even have a budget from them to buy any filament I want to test. Let's see a few specifications from the website. This is polycarbonate reinforced with 10% carbon fibers, high impact resistance, excellent rigidity. This means the resist good to the bending, thermal resistance up to 150 degrees Celsius, and low shrinkage. This means better dimensional accuracy. And from this, I believe that more or less it is correct, except this high impact resistance, because adding fibers will make the material more brittle compared to no fiber version. But this will be measured in this video too. Let's see some print settings. The nozzle temperature between 270 and 330 degrees Celsius, bed between 90 and 130 degrees Celsius, cooling between 0 and 20%, speed up to 120 millimeters per second, and of course it has to be dry filament. I noticed quite big differences in the given informations, so this is from their website, this is from the shop, and this is from TDS PDF, huge difference in the recommended print settings. And one more thing they mentioned, a nozzle larger than 0.4 mm, and of course we need some hardened steel nozzle or similar. Yes, it is always a big question which nozzle to use in this case. Follow the instructions or stay with 0.4 and to see if I will have a clog or not. And actually I'm preparing some PCCF comparison video. I have already 5 brands here and I want to use the same nozzle, so maybe this will be printed with 0.6 mm, and in that comparison video maybe I will use 0.4, but at this moment I'm not sure yet. Let's see what's in the box. Vacuum packaging, but in this cheaper material. Let's see how brittle is the filament. Not too brittle. Let's try to measure it. Start angle 22 degrees. Now it was broken. I will check the footage. Slicer settings. I started from generic PPA CF profile, chamber 60 degrees Celsius, on the bed 120, nozzle 320 as maximal recommended, maximal flow 10 cubic millimeters per second, cooling between 0 and 35%, and I increased the minimal layer printing time to 4 seconds. My regular test objects. The start is good, but I maximize here several temperatures, bed and the chamber. Not the cleanest printing. Maybe I could dry the filament, but it's too late now. Just quickly the bed adhesion check. Okay, it's good. Let's check that oozing test. I'm extruding a little bit filament. Yes, it is oozing a lot. Pity, I should dry the filament. Especially these 4 are in quite bad shape, a lot of stringing here. I will dry the filament and maybe reprint only these 4, I'm not sure at this moment, because this is very small spool and I also want to use this filament in PCCF comparison video. The drying is not easy because this is so small spool. Total drying time was 8 hours on 70 degrees Celsius. Looks promising so far. Look at this difference. And I think first time I will keep both test objects and I will do some comparison wet versus dry filament. Open end wrench, because I'm preparing 5 PCCF comparison video and this will be one of the tests. These test objects are for the separate video where I will compare 5 PCCF brands. I just checked the footages. These objects are printed 3 months ago. So this was printed from dry and this from the wet filament, but by now they should be in similar state. Let's measure the shrinking first. Printed from dry filament. I'll try to measure above the elephant foot. And 79.89, the design length is 80 millimeters, so it has some minimal shrinking, but much smaller compared to, for example, average ABS. This was printed from wet filament, and this should be bigger because of that over extrusion. Oh yes, definitely much bigger, 80.41. Definitely this was printed from wet filament. If you want to know more about this method, you can check this video. I explain very detailedly the method. Now you may think that the stringing is easy for cleaning, using the flash cutter or heat gun. Yes, it is, but don't forget the stringing is result of oozing from the nozzle, and that material will missing from the object itself, and in theory this should be weaker. Tensile test horizontally printed objects. This was with dry filament, and now wet. Small advantage on objects printed from dry filament is stronger by approximately 10%. Layer adhesion, vertically printed objects. And now wet. I want to check something. Is maybe 320 too high temperature? I know with PTG we have a max where it starts to degrade and we will have a weaker layer adhesion. Maybe something similar we have with this PCCF. Printing on 300 degrees Celsius. Dry, wet, and this is when printed on 300 degrees Celsius, and this is the average from 4. Here you can see my rating for this size of the test object. And looks like on 300 degrees Celsius it is stronger a little bit compared to 320 degrees Celsius. So maybe there is some maximum for this filament, I'm not sure. Maybe this is coincident because actually the difference here is not so big. But looks like the wet filament has a weaker layer adhesion, which is normal. If you have a lot of stringing, it will reduce the material used for the object. Shear test horizontal printed objects. Specimens printed in vertical position. Printed in horizontal position, small advantage on the objects printed from dry filament compared to the wet, but the difference is not big. In vertical position, we can see bigger difference, and this is something what I expect when I see a lot of stringing. That material which is in the string should be in the object, and that's why the wet filament is weaker in this case. Torsion test. Loaded 90 degree rotation. The maximal load in Newton meters. Printed in vertical position. The maximal load. Actually not bad, but this one printed in horizontal position could perform even better, but weaker layer adhesion means weaker wall adhesion too, which we can see on this test object. Printed in horizontal position, loaded 90 degree rotation. Printed vertically, this is the maximal load, and we can see it is equal. Now something I noticed, because if you follow my channel, then you know that this load should be very similar to this one, but it's lower, and that's normal because it has very weak layer adhesion. 3-point bending test. Distance between supports is 50 mm, and these loads are placed one by one every 1 minute, and I'm measuring the deformation after 1, 30 and 60 seconds. And currently this is a deformation under 10 kilograms. And no visual deformation after this test. This is an interesting one. We can see until 5 kilograms the deformation is very similar, but under 10 kilograms we can see more additional deformation on the objects printed from wet filament. Another 3-point bending test follows the ISO 178 standard. Even the break type was different. The graph, load in function of time or deformation, bending strength and elastic modulus. The bending strength is calculated from the maximal load, and we can see the advantage on the objects printed from dry filament compared to this one. And similar ratio we can see with the elastic modulus, and I think this is one of the biggest advantage of the drying. ISO impact test. Side by side result from 3 measurings. And now moving to the Sharpie hammer. Sharpie impact test, and the object is supported from 2 sides. And again 3 plus 3 measurings, but let's see the graph. These two experiments are different standards, so these numbers shouldn't be compared to each other, but the ratio between filaments is the same, and we can see a very small advantage on the objects printed from dry filament. It is minimally tougher, but the difference is really negligible in this case. Creep test, the deformation under constant load of 1.25 kilograms. 13.12. 13.00. Day 5, the last measuring. 13.28. 13.07. After removing the load, visually no difference and no permanent deformation on the objects. On this graph we can see the distance between two reference surfaces, and we can see a little bit more deformation on the wet filament, but the creeping is the difference between 2 days, and that's presented on the second graph. And we can see the creeping is basically minimum, almost zero after day 2. Only on first day we have some little bit bigger creeping on the wet filament. Temperature test in the oven, and these two objects are from this video. Speed up, timeless video. Some ABS materials I have to take out earlier. And these two objects started to deform at 134 degrees Celsius. Our results one more time. Creep test, tensile test, layer adhesion, shear test, horizontal and vertical, bending test, deformation after 30 seconds, bending test, deformation under these loads after 1, 30 and 60 seconds, torsion test, horizontal and vertical, impact test, ISO and Sharpie, temperature test, and that second bending test, ISO 178. For the end, but it's quite obvious that the dry filament is better, not only for the aesthetic look, but also for the strength. Now, to be honest, I thought that the difference will be bigger. In most cases it was almost negligible. I think the biggest difference we can see with the bending related stress, and somehow I don't really like this weak layer adhesion, even if it was printed on 320 degrees Celsius, which I almost never use for the PCCF filaments. Anyway, this was my experience with the Spectrum PCCF filament, and it will be included in that 8 PCCF brand comparison video. And if you would like to get a notification about that new upload, in that case maybe you should consider subscribing and enabling that notification bell button too, because for some reason, I'm not sure why, but even my regular subscribers are not informed about my new uploads. Anyway, thank you for watching this video till the end, and as always, happy printing!